See this question, which of the following is not an equivalence relation on the set of all real numbers? So they are talking about set of all real numbers. Using the set of all real numbers, we are forming a relation. So what does it mean? If you take set of all real numbers as capital R, then you take R cross R. Then we are talking about the relations which are possible from R cross R. Okay. Now they are saying which of the following is equivalence, is not an equivalence relation. So first one is R1 equal to A comma B in such a way that A minus B is an integer. So what they mean by this one is R1 contains set of all ordered pairs in such a way that A minus B is going to be an integer. For example, R1 contains 1 comma 2. They are asking whether such a relation R1 is going to be equivalence relation or not. Okay, so I'm just saying what will R1 contain. R1 will contain any set of numbers, any ordered pair of two numbers in such a way that A minus B is going to be an integer. For example, it might contain 0.5 comma 1.5. The reason is the difference is an integer. Got it? So you can take any 2 points on the real number and see the difference. If the difference is an integer, then you include it in the relation. Now what is that type of relation? Is it going to be equivalence? So if you have to test whether the relation is equivalent or not, you have to test whether it is first reflexive, then symmetric, then transitive. All these three we have to test. Now let's see this. If the relation R1 has to be equivalent, reflexive, first I'm talking about this, okay? It has to satisfy a reflexive property, then symmetric, then transitive. Now if it has to satisfy the reflexive property, then it should contain all the pairs of form A comma A, right? So when will A comma A be a part of it? It will be a part only when A minus A is an integer. In fact, A minus A is 0, which is an integer, and so we can say that all the diagonal pairs will be present in R1. Are you getting this? See, all the diagonal pairs of form 1 comma 1, 2 comma 2, so on should be present in this relation. Then only we can say that this relation is going to be reflexive. Now, if you take 1 comma 1, will it be present in the relation? Yes. The reason is 1 minus 1 is 0, which is an integer, and that is the requirement. If A minus B is an integer, then it is going to be present. So since 1 minus 1 is 0, which is an integer, and so 1 minus 1 will be included in the relation R1, and so we can say that it is reflexive. Now what can we say about symmetric? Is it going to be a symmetric relation or not? So how can we test it? So if you have A comma B belonging to the relation, then B comma A should also be belonging to the relation, right? Now when will A comma B belong, when will A comma B will belong to the relation? When the difference A minus B is an integer. If A minus B is an integer, then definitely B minus A is the negative of that integer, which is again an integer. For example, if A minus B happens to be 10, then B minus A happens to be minus 10, which is also an integer. Therefore, if you have A comma B an element in the relation, definitely B comma A will also be present there. So we can say that all the symmetric pairs will definitely be present in this relation, and so it is symmetric. What about transitivity? So transitivity says that if you have two relations or two ordered pairs A comma B and B comma C, right, then we should also contain A comma C in the relation. Then only the relation is going to be transitive. Now let's see this. Now we are saying that A comma B is present, and then B comma C is present. Then we should check whether A comma C will be present or not. Now when will A comma B be present? If A minus B is an integer, right? And when will B comma C be present? If B minus C is an integer. This is an integer and this is an integer. That is what we know as of now. Now if we have two integers, just add them. Then what do I get? A minus C. So if A minus B is an integer, if there is an integer and integer, sum of two integers is definitely going to be an integer. Therefore a minus c is also going to be an integer. Then what can we say? We can say that a comma c will also belong to the relation. Are you getting this? I am assuming that a comma b belongs to R, the relation R1, this one, right? So how will it belong to R1? Only when a minus b is an integer, which means a minus b is definitely an integer. Then I am assuming that b comma c also belongs to the R1, which means b minus c is also an integer. Now I am adding two integers, then I got a minus c, which will definitely be an integer. Why? Sum of two integers is definitely going to be an integer, and therefore a comma c will also belong to I, right? And so for every pair a comma b, b comma c, there will also be a ordered pair a comma c, which will be present in the relation, and so it is going to be transitive as well. So the first relation R1 is definitely equivalent. So that is how you should test whether a relation is equivalence or not. Test whether it is reflexive, symmetric, transitive. 3 points. Now look at the next one. They are saying that a comma b is R2 is a relation in such a way that it contains a comma b only when a minus b is divisible by 5. So what is the meaning of it? Two numbers will be present as an ordered pair only when a minus b, if you take the difference, it should be divisible by 5. For example, you will have 1 comma 6, right? Or you will have 2 comma 7, right? Or you will have 7 comma 2, like this. Why? Because if you take a minus b, the difference is 5, so 5 is divisible by 5. Or you will have 1 comma 11, the difference is 10. Or you will have 11 comma 1, right? Or you will have 101 comma 1, something like this. So you will have a lot of numbers like this. So what I am trying to say is, a ordered pair will be present in this relation R2 only when, if you take the difference and if you get the number, if that number is divisible by 5. In all these cases, the difference is going to be divisible by 5, right? So that is the example of this relation. Now we are supposed to know or show, find out whether this one is equivalence or not. How can we say whether it is equivalence or not? We have to test three conditions: reflexivity, and then symmetric, and transitivity. So let's see whether it is reflexive or not. What does reflexive mean? Will it contain all the diagonal elements of form a comma a, which means will it contain 1 comma 1, 2 comma 2, all these elements of type? Yes, it will contain. The reason is, if I take a minus b, it is 0, and 0 is divisible by 5, right? A minus b is divisible by 5, 0 is divisible by 5, and so it will contain all the pairs of type a comma a. It need not be only integers. You can even have 0.5 comma 0.5. Every real number, you take any real number, and if you take the pair of it, then it is going to be present in the relation. The reason is, a minus a is going to be 0, and 0 is going to be divisible by 5. Therefore it is reflexive. What about symmetric? What can you say about it? Now what does symmetric mean? If a minus b belongs to relation, so what does it mean? A minus b should be divisible by 5. So which means you should be able to write a minus b as 5 into k, where k is a integer, right? Then if this is the case, then what can you say about b minus a? B minus a will be 5 into minus 5 into k, which is nothing but 5 into minus k, which means again b minus a is also divisible by 5. If you have any pair a comma b in such a way that a minus b is divisible by 5, then definitely b minus a will also be divisible by 5. For example, if you take 2 comma 7, so where 2 minus 7 is minus 5, it is divisible by 5. Then 7 comma 2 is 5, which is also divisible by 5. Therefore what can we say? If there is a comma b, there will be b comma a in the same relation. Therefore we can say that it is symmetric. Then what about transitivity? What does transitivity say? Transitivity says that if a comma b belongs to the relation and b comma c belongs to the relation, then a comma c should belong to the relation. Now let us assume that these two belong to the relation. Then what does it mean? A minus b is going to be some phi k, right? Why? Because if it belongs to the relation, definitely a minus b is divisible by 5. That is why I am writing it as 5k. And since b minus c also we are assuming that it belongs to the relation, equal to 5m, right? Now when you add these two, then what do we get? When we add these two, we get a minus c is equal to 5 into k plus m, where k and m are integers, and so we can say that it is again divisible by 5. Therefore a minus c, since it is divisible by 5, a comma c belongs to the relation, and so we can say that it is transitive. So we can say that R2 is also equivalent relation. What about R3? A comma b such that a minus b is an odd number. So you get all the numbers only when the difference is an odd number. For example, if you have 1 comma 4, the difference is an odd number, therefore it will present in the relation. If you have 1 comma 3, the difference is not an odd number, therefore it will not be present. Got it? So that is what they are asking. So even numbers and odd numbers means like this. So for this example R3, all the numbers of type a comma b will be present only when a minus b is an odd number. For example 1 comma 4, but 1 comma 3 cannot be present. Now what can you say about it? Will it be reflexive? Let's test that one first. So when can we say that it is reflexive? Only when you are going to have all the numbers of type a comma a. Now if you try to put a comma a in this relation, it will not fit in. The reason is a minus a is equal to 0, which is not an odd number, it is an even number, right? Therefore the relation R3 will fail to be reflexive, and so it cannot be equivalent as well. Therefore C cannot be equivalent relation. What about D? A minus B such that a minus b is an even number. So check this. So they are talking about even numbers now. Will a comma a be present? Yes, a comma a will be present because a minus a is 0, which is an even number. Therefore it is definitely reflexive. So now let's test whether it is symmetric or not. So how can we test whether it is symmetric or not? In order to test symmetric, we have to test like this. If a comma b is present, then will b comma a be present there. Now when will a comma b be present? Only if it is 2k, which means the difference a minus b is equal to 2k, which is an even number, right, where k is an integer. Now if a minus b is 2k, then what do you think about b minus a? It will be minus 2k. Again it is also an even number. Therefore if a comma b is present, then b comma a will definitely be present, and so we can say that it is symmetric, right? What about transitivity? So transitivity, not to prove that, we have to assume that, let us say a comma b belongs to the relation R4 and b comma a belongs to the relation R4, b comma c belongs to the relation R4, then we have to show that a comma c will belong to the relation R4. How can we show it? Since a comma b belongs to R4, we can say that a minus b is equal to 2k, and since b comma c belongs to R4, we can say that b minus c is equal to 2l for some integers k and l. The reason is the difference is going to be an even number, that is why I am writing it as 2k and 2l. Now you add them both, then what do we get? A minus c is equal to 2 into k plus l. Now what can we say? The difference a minus c is also an even number, and so a comma c will belong to the relation, and so we can say that it is transitive as well. So only relation which failed to be transitive is R3. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.